We are here today again to look at a very fascinating topic known as periodic table. Last time we met, we talked about the atomic model and atomic structure. The objective of the lesson today would be to describe the periodic table and also state the difference between element and compound, navigate around the periodic table, observe the trends of elements on the periodic table. And one interesting aspect we are going to be looking at is the history, the development process that the periodic table had followed from many years ago to where we are today. The dictionary for chemistry is regarded as a periodic table, okay, because it has all the ingredients that makes up the universe represented in a table, okay? So, and they are listed in a particular pattern, which we're going to be observing today. And this pattern also have great implication on the properties of the elements in each group as we look at the periodic table today. So a good example of what the periodic table looks like is what we have here. You can see on the left side of my screen, you have a table with blue color, cream color, brown, and purple. And you also have green color. Now, when you observe this table, you would notice we have various elements represented with their symbols on this periodic table. The colors you can see here represents the type of elements you can find. The very reactive metals are the ones that are colored blue, okay? And you can see the number at the top here representing what we call group. So the periodic table has groups and has period. We have 7 periods and we have 8 groups on the periodic table. We have 8 groups on the periodic table. And these groups are, we have group 1, 1, 2, 3, up to 4, 5, 6, 7, and 0. So those are the groups we have on the periodic table. For periods, we have period 1 to 7. These are illustrated on this table, as you can see. The vertical columns represent your group. So we have 1 here. So that means lithium, sodium, potassium, rubidium, calcium, all belong to group 1. And then group 2, beryllium, magnesium, follows that trend to group 2. And then we skip this yellow region and move on to group 3 here. Okay. And then group 4, group 5, 6, 7, and 0. Okay, so those are the 8 main groups we have on the periodic table. When you look at the number of rows we have, you will observe we have 7 rows on the periodic table. The first row is period 1, as you can see. The second row, containing lithium up till neon, is period 2. Okay, and then period 4, as you can see, covers element from potassium, that is symbol K, straight to krypton. Okay, so that is how to read this table. Let's pick one element and let's see whether we can tell what group and period that element belongs to. Let's pick boron, for example, B. If you trace this upward, you will notice this belongs to column 3. That is group 3. Okay, you can see 3 at the top. So this is group 3. And then for you to know the period, you will trace the row to this point. So it belongs to group 3, period 2. Okay. You can pick other elements such as sulfur. Sulfur belongs to, if you trace it up, you know this is the group 6 and then period 3. So this is how elements are placed on the periodic table. So if you want to determine the group an element belongs to, or the period an element belongs to, you simply just have to just look for the column the element is located and also the row. Okay, so remember the row indicates your period, okay, and then the column represents your group. Okay, so take note of that. All right, so we move on to how this element, how the periodic table were developed. Okay, but before we do that, remember I told you about the colors on this table. Okay, so you have your yellow, which represents your transition metals. You have your orange color here, which represents some metals. You have the purple ones. You can see boron, silicon, germanium, arsenic, beryllium. All these are known as metalloids. The key are by the side of the period table. So you can just look at the key and see what each color represents. However, you need to take note that different texts use different colors to represent these elements. So in some texts, you may see colors that are different from what we have here. Okay, the key is looking out for the key and using it to know what kind of elements are represented in each column. Okay, if you look at this periodic table, you will notice we have more of metals. The whole of group 1, group 2, that is this blue region, the entire yellow region here also represents the entire yellow region here, and the orange region here all represents your metals. So it means your non-metals can be taken from this point. These are your non-metals, okay, from here, from this point to this point. Okay, so you can see we have very few non-metals. We have more metals. So metals covers all the way to this region. So everything here are metals. So you can see from here to this point are all metals. So it simply means that over 75% of the elements you can find on the periodic table are metals. In our next class, we'll be looking at metals and non-metals. Okay, so ensure you remember to click the button below at the end of this class to subscribe and like this video. And you can also share this video, okay, so that you will always be updated on the next thing we are going to treat. Like I announced, we are going to be treating metals and non-metals in our next class. So if you don't want to miss out, ensure you hit the button below this video and subscribe. Okay, so how did this periodic table come to be? that is where we're going to end the class today. How was it developed? Was it this beautiful from beginning? Of course, everything started in a crude manner before they look so beautiful and easy to use today. This is how the periodic table looks like when the Russian chemist Dmitry Mendeleev developed the periodic table, okay, in 1869. If you notice this periodic table, you will see that he also observed the 8 groups, okay? You will notice he observed 8 groups from group 1 to group 8. 1 is group 1 up to group 8. Take note, group 8 is also known as group 0. We use that interchangeably, okay? So, you also notice he had periods by the side, okay? And also, you would notice that the elements are just arranged according to their mass number, unlike the beautiful one we just did or treated. That one, which is what we use today, the elements are arranged according to their atomic number, not mass number. Okay, that is one difference between what Mendeleev designed and what we use today. Okay, so the major differences are: one, the modern one table, the elements are arranged according to their atomic number. Okay, so that is for the modern periodic table. Okay, then the old periodic table, as you can see, has so many spaces in them. Okay, you can see it has so many spaces in it. Let me show you some of these spaces. Anywhere you see dash, you can see there's a space here, there's a space here, there's a space here, there's a space here, and so on. Dmitry actually left those spaces for more discoveries, because he noticed that they had little element discovered there. So with the mindset that more elements will be discovered in the future, hence he created those spaces so that more elements can actually fit in. Was he right to do so? Of course, he did the right thing, because if not for that, we would not have the beautiful periodic table we use today. If you observe the periodic table we use currently, you would notice that there is no space. Everything is completely what? Filled out. Okay. So it simply showed that it will be difficult for more elements to be discovered. Okay. Except for those that are artificially made by bombardment. But naturally, there are no more elements in nature yet to be discovered. Okay, all the elements that needs to be discovered naturally, that are stable, have been discovered and have taken their place on the modern periodic table. Okay, there are extensions to this periodic table known as lanthanides and actinides, which we're going to discuss in the next class. They give room for more artificial elements to be discovered. The ones produced in the laboratories that cannot survive more than a second. Once they are produced within a second, they will break down to what they were before. So they are not stable elements. So they are placed under that extension. Okay, but the ones we have here are the stable ones that occurs naturally in nature. Okay, so that is all about the periodic table, the development of the periodic table. For you to know more, you know what to do. Like this video, click the subscribe button. Till we meet again, thank you for listening and bye.